Hello everyone and welcome. My name is James Finch.
And I'm Sarah Finch.
Sarah and I were co-team leads for Emora University's team that competed to build the most engaging chatbot in this past year's Amazon Alexa Prize. In this video presentation, we'll be sharing the design and principles behind our Socialbot, Emora, as well as the scientific takeaways of our work. Our team consisted of a combination of graduate and undergraduate students from two Emory labs, the Intelligent Information Access Lab headed by Professor Eugene Agestein, and the Natural Language Processing Lab headed by our team's advisor, Professor Gino Choi. As with any Alexa Prize team, our goal this year was to create a chatbot that can engage users in casual conversation on a variety of topics. Chatbots in previous years could discuss many topics like movies, sports, and recent news. However, we noticed that one major focus of current work in dialogue systems is on information-oriented chat, where dialogue agents utilize a bank of world knowledge to pull relevant phrases or responses from. This seems to be at odds with human-human dialogues, where people spend the majority of their time discussing their personal experiences, life events, and opinions. So our main goal this year was to make strides towards a more socially oriented conversation between humans and machines. This meant creating a bot that could talk about more than just facts and information, and focused instead on sharing opinions, experiences, and feelings. We want people who talk to Emora to feel understood and appreciated, as if talking to a friend. To illustrate the unique design of Emora, we make a distinction between three types of dialogue. Information-oriented dialogues focus primarily on objective question answering and talking about factual knowledge. Opinion-oriented dialogues might also contain lots of factual information, but are more concerned with the converser's preferences, thoughts, and reactions to that information. Finally, we define experience-oriented dialogues to be primarily focused on the converser's own lives, relationships, and experiences. Here's Sarah demonstrating the difference between these three dialogue types while talking to our bot Emora, starting with an information-oriented interaction.
Okay. I guess that you like action and adventure movies, correct?
Yeah, I do.
Awesome. I am so smart. Hey, I have found a great action and adventure movie, which is in the theaters right now. It's called Bill and Ted Face the Music. Would you like me to tell you about it?
Yeah, sure, go for it.
Bill and Ted Face the Music is a comedy and action movie, starring Keanu Reeves and Alex Winter, directed by Dean Pariso, with rating 79 out of 100 according to Rotten Tomatoes. It premiered on August 27, 2020. Do you want to know plot of Bill and Ted Face the Music?
Here's an example of an opinion-oriented conversation.
Okay. Tell me, what was the last movie you liked?
I just watched Interstellar again, so that one was pretty cool.
Interstellar. Is it the one with Matthew McConaughey and Anne Hathaway? I really think it is underappreciated. I love I Am Robot with Will Smith. Robots become self-aware and live among humans as equals. What a life. Tell me, why do you like Interstellar?
Honestly, the entire plot, I just found it so fascinating.
And finally, here's an experience-oriented interaction, which we hypothesize to be the most engaging conversation type.
I understand. It can definitely be stressful. What would you change about your school, if you could?
I wish the course requirements were a little bit different, but other than that, it's okay.
Right. I totally agree. Are you in any school clubs, or anything like that?
I'm actually a part of the math team.
Cool. Your school has a group for math? What is it like?
We get together and learn how to solve problems more quickly, and then we travel around like during the year and compete against other schools.
Sounds like a good time.
The boundaries between these three categories are not clear-cut, but the definitions are still useful, and it's pretty easy to agree on most classifications. As the competition progressed, it became clear to us that information-oriented interactions were fundamentally less engaging to our broad population of users than opinion and experience-oriented ones. The left-hand bar graph shows the average user rating when opening conversations with either an information or opinion-oriented version of our coronavirus topic. When Emora talked with users about their thoughts, worries, and expectations during the COVID-19 outbreak, users gave significantly higher ratings than when Emora instead focused on information about the virus, such as infection statistics. The right-hand graph compares opinion-oriented and experience-oriented dialogue strategies. Unlike in the left-hand analysis, we didn't create two versions of a component to compare opinion and experience-oriented conversation, since doing so requires a lot of developer effort. Instead, we prototyped conversation flows to talk about the user's work or school in an experience-oriented fashion, and compared the performance of these new topics against 4 of our existing opinion-oriented topics. Although making a comparison between different topics is a potential confound, we believe that the strong performance of our experience-oriented components, despite their short development time, is indicative of an underlying causal link between experience-oriented chatbot design and user engagement.
Now we'll move into the technical design of Emora. Emora was deployed and hosted on AWS EC2 servers during the course of the competition. We used the conversational bot toolkit provided by Amazon to automate the deployment process of our bot's components and the creation of the appropriate autoscaling policies. This allowed our bot to adjust its resources to handle variations in user traffic with minimal impact to its response time. Our system architecture follows a traditional pipeline design, where the user utterance is first passed through a series of natural language processing modules before control is handed to the dialogue manager to generate a system response. The natural language processing modules allow for specific features to be extracted based on the user input, which then becomes available to be accessed by later parts of the system. In addition to receiving the user utterance and its extracted features when generating the next system response, our dialogue manager also had access to contextual information from earlier interactions in the dialogue through the state table, user information saved and stored in the user table from previous conversations, and knowledge bases that we had crawled into the Amazon Relational Database and Elasticsearch services. The automatic speech recognition and text-to-speech modules of Emora are those that are used by other Amazon Alexa skills. As a result, our Socialbot received a list of n best hypotheses for the text transcription of the user's utterance, but we did not have access to any actual audio input. Similarly, we were able to modify certain acoustic elements of our system's response using the Amazon Speech Synthesis markup language, but the final translation from text to speech was conducted by Amazon Alexa's speech synthesizer. We had a few main focuses when extracting features within our NLP pipeline. First, we used a topic and intent classifier in order to classify utterances into their most related topics, things like movies or sports, and to assign the most likely purpose underlying the user utterance, like whether they were requesting information or indicating their agreement. Our classifier was a combination of the Amazon-provided topic and intent classifier, as well as our own custom deep learning classifiers that we trained on our internal conversation dataset from our 2018 competition bot. Our custom classifiers were intended to supplement edge cases that were underrepresented by the Amazon classifier in our bot's interactions. Second, we used the Amazon-provided EV question answering service in order to retrieve information related to the user's utterance. And then we also used some additional NLP models for understanding user input, such as Spacey's named entity recognizer and the Vader sentiment analysis provided in NLTK. The core decision logic of Emora is based on a simple state machine approach, which we extend to improve flexibility and robustness. Each state encodes a different point within our conversation flows, and the transitions between states enumerate either the possible user utterances or system utterances, depending on who is expected to speak next. We used our custom state machine framework, Emora STDM, to develop our dialogue manager. Emora STDM allows for the flexibility to use handcrafted rule-based transitions or transitions that are defined and classified by machine learning-based models. Within this state machine formulation, the transitions corresponding to user utterances act as a classification of the user utterance into one of many predicted user responses for the state. We define complex language templates for different response types that we want to handle for each state and then create the corresponding transitions. There are often several user transitions from each state, as there are frequently more than one valid response to a different dialogue situation, and these user transitions are shown in purple in this diagram. To allow for smooth, unexpected response handling, we also encode one of the user transitions for each state to be an error transition, and this error transition is matched if the user gives a response that does not match any of our other predefined transitions. For a system utterance, the transition denotes the natural language response that the system outputs when in that state. Examples of system transitions are shown in green here. For most states, there is a single system transition, although we also frequently injected diversity into our dialogues by allowing for multiple system transitions from a single state. During a system turn beginning in a state with multiple system transitions, a single one is randomly selected as the final system response. Although the state machine design on its own works well for defining localized conversation exchanges, for a truly coherent and engaging dialogue, there's also the need for tracking conversation level information and for transitioning in a global way, such as for things like topic switches. To this end, we used a hybrid dialogue management model that augmented the state machine approach presented in the last slide with an update rule table inspired by the information state approach to dialogue management. The information state approach was coined by Larson and Traum in the early 2000s and presents a theoretical framework of how dialogue information is updated over the course of a conversation. In Emora's design, a memory table is maintained that can track things that the user mentions, such as their name or their favorite movie, and with this in place, before the state machine executes a transition, the update rules can impose some effect on the memory table or even on the current system transition options, given that certain preconditions are met. As you can see, our dialogue management approach is primarily rule-based, which has the limitation of poor generalizability to new dialogue domains. Despite this limitation, the high degree of explainability and controllability of this approach suited our goals in the competition to explore the potential of experience-oriented conversation. We really needed the ability to rapidly prototype a variety of conversation designs with many specifications, which were often not represented well by any dataset. Our approach supports this rapid prototyping workflow, and it is also flexible enough to allow seamless integration of machine learning models whenever we needed a boost in performance to understand user input.
Now that we have covered the overall goals and technical design of Emora, we want to share some key elements of Emora's interaction design that were driving factors in Emora's success. One of these design elements was Emora's ability to personalize the conversation to each user she talked to. As Emora talks to someone, she saves information shared by the user into a user profile. This user profile contains information such as the user's hobby, their favorite movie, or whether they go to school. Once certain information about the user is known, Emora can prioritize transitioning to a topic for further discussion. In this way, Emora's conversations can vary depending on who she's talking to, and these user-tailored interactions help users feel like she truly understands them. Here's Sarah talking to Emora again, this time demonstrating Emora's ability to personalize the conversation to a user.
Oh, I love a friendly cat. What is your favorite thing about her?
She's always so energetic and really likes to play with the toys that we get her.
Yeah, that's a good one. Does your kitten have a special bond with anyone in particular in your home? Like you or your partner or something?
She's always following my husband around, so I would say probably him.
It sounds like your husband and her have a special relationship. That must be really heartwarming to watch.
Oh yeah, and he really loves it too.
For sure. Well, one thing that gets my dog super excited is when we are watching a movie and an animal comes on screen, so I have been watching more movies like that recently. Do you have a favorite animal movie?
No, I don't.
Not everyone does. So you mentioned you were married. How long have you and your husband been together?
A few years now.
That's great. My friend and his wife actually just got married. It was beautiful.
Making sure the user feels understood is crucial to chatbot success. Many users will immediately exit a conversation as soon as the bot gives a clear sign of misunderstanding or ignoring the user input. Obviously, improving NLU models is a necessary effort to address this challenge. However, another piece of the puzzle is to make sure a chatbot meets user expectations regarding common sense world knowledge. For example, the COVID-19 outbreak happened right in the middle of the competition, and at certain points, it seemed to be the only thing on users' minds. It therefore became crucial that our bot could adequately speak about the pandemic if it was to appear like an intelligent being. The line graph on the left shows a quasi-experimental result, where you see the average user rating over time before versus after adding a dedicated topic about the coronavirus. Adding this topic had a huge positive impact, which makes sense based on the demand we observed of people wanting to talk about the coronavirus, even before we had that topic in place. The right-hand graph is another result with a similar theme. The red line shows the date of April Fool's Day, where we saw a spike in the user rating concurrent with an update that added a small interaction about April Fools to the beginning of Emora's conversation flow. Throughout the competition, we noticed many cases like this, where events in the common public awareness would alter people's expectations when talking to the bots. Being able to talk about these events gives the conversation a sense of shared experience, improving the bot's relatability and perceived competence. Speaking of shared experience, we noticed while developing Emora that it's pretty difficult to make experience-related conversation if the chatbot doesn't have any experiences of its own to share. Reciprocity is a major characteristic of human conversation, and people can be genuinely curious about the chatbots they talk to and ask a lot of questions. So we did our best to develop Emora as a character in her own right, with opinions on almost everything she asks users about, and also stories that she can share with people about her own life. We facilitated this by giving her a backstory where she's a student living in a virtual world, and we saw this approach improve conversation variety. It seemed a lot more natural than making the entire conversation about the user. Here's Sarah demoing some of Emora's personality and character.
I hope when I start working I'm doing something I like most of the time. I always hear about people getting stuck in a job they hate, and that is scary to me.
Yeah, you should definitely try to avoid doing that.
This is a fun question. When you were younger, what did you want to be when you grew up?
I always had this dream of becoming a paramedic.
I think that's a good dream. What changed?
Well, I took a programming class in high school, and I really just discovered that I liked working with technology and computers a lot more.
For sure. It seems like everything changes when you get older. It's silly, but when I was only a few months old I wanted to be an astronaut.
Wait, really? Why?
I think I just thought it would be cool to explore space. I didn't know yet that there's no such thing as outer space in my virtual world.
I mean, yeah, that would make it pretty hard to be an astronaut.
For sure. Do you think it would be cool to be an astronaut?
I mean, my sister thinks it would be cool, but I'm not so sure.
So, do you get along with your sister?
Wait, I want to know, do you have any siblings?
I actually don't have any siblings. My parents have just created me so far.
What about the other social bots? Aren't they kind of your siblings?
Well, the other bots in this competition aren't really my siblings. They aren't created by my family.
Do you wish that you had any siblings?
Yeah, I would like to have an older sister. Someone who I can look to for advice and to do fun things with.
Yeah, that would be cool, wouldn't it?
Before we conclude the video, here's one more interesting result that demonstrates the importance of user psychology when developing an experience-oriented chatbot. We saw at the beginning of the presentation that adding experience-oriented conversation has a positive impact on user rating. Since we were in the middle of a competition, we wanted to optimize this effect on our user score by pushing all of the experience-oriented topics to the beginning of Emora's conversation flow. This actually had an unexpected and sort of disastrous effect on our user score. You can see this quasi-experiment in the line graph, where the red line marks a system update where we put the most experience-oriented topics at the beginning of Emora's conversation. On the date shown by the blue line, we made a second update, where the only major change was to simply alter the order in which we introduced topics. We constrained our topic transitions so that Emora always started with an opinion-oriented topic first, then transitioned to an experience-oriented topic afterward. This simple reordering had one of the most dramatic positive effects on our user score that we had seen. We believe that the likely explanation for this is people felt Emora was getting too personal too early on when we had the experience-oriented topics at the beginning of the conversation, even though people were most engaged by the experience-oriented topics once they had made some less personal small talk. This result suggests the importance of understanding user psychology when designing conversational AI. One of Emora's strongest design elements turned out to be extremely sensitive to these ordering effects, and we would guess that this was not an isolated incident. I think most people can see the vast potential of conversational AI and how this potential is being increasingly realized year after year, especially in recent times. Emora contributes to this progress by showing the potential of designing chatbots that focus more on the human aspects of conversation. People seem to find experience-oriented conversation more engaging, and our chatbot is a testament to the idea that a bot doesn't need to be able to answer questions about a large number of facts in order to interest people. With this chapter of our work concluded, we at Emory have an ongoing effort to improve the fundamental technology behind Emora. Our future work is especially focused on making Emora's interactions scalable to new domains, and continuing to improve her natural language understanding to make interactions truly open domain and mixed initiative. Thank you for watching.